Hi everyone. Today I'm here to talk about building software with failures as norm. Basically, accepting that failures are bound to happen and be prepared to mitigate them instead. A bit about myself. I am Surabhi. I am a software engineer at Foodpanda. My interest and focus is to improve myself at designing well architected systems and share surrounding best practices. I'd like to start by saying this. In order to develop and launch products reliably, it is essential to build stable software so customers don't have a bad experience. Few examples of bad customer experiences could be customers trying to pay but is unable to, or trying to apply a voucher code but seeing a weird exception on the screen. We all can relate to this. Therefore, it's important to consider and mitigate failures to provide the best customer experience possible. I think we all agree on that. Well, the aim of my topic is threefold. First of all, is to raise awareness on treating failures as a norm. And secondly, to share approaches which tackle failure scenarios. And thirdly, provide ways to validate if software is ready for real world. Each of the techniques that I'll be talking about are quite broad, and you might have to deep dive to understand each of these better. However, these provide a good starting point for thinking in terms of reliable software. With that said, failures could be of various types. Say, an unhandled error that looks something like this, to a data center catching fire. Why think about failures in the first place? If your system has failures, it could lead to outage, and that in turn could lead to unhappy customers, and which leads to financial losses to the organization. The impact of financial loss to an organization is quite high in itself, but apart from that, it also impacts branding as well. And eventually, customers tend to lose trust in your product or application. So let's talk about SLA, which is a new term that we are trying to learn here. Usually, it's an agreement between a service provider and their customer or consumers, which define the level of uptime of the service. Okay, when we say about uptime, it is essentially availability. How long is your service available for? When we say 99% availability, that means that it could be down for, let's say, about 14 minutes a day or 3.65 days a year. So if you see as the number of nines after the dot, when you say 99.9 or 99.99% availability, the amount of downtime decreases. So this means that your application needs to be robust enough to provide that much or that level of uptime. All right. Well, a ton of situations could affect your application hosted anywhere, either on prem or in cloud. For example, latency, availability, or failures in your storage systems like databases, etc. Therefore, it's important to keep track of other services being used by your application as part of your SLA. Now that we are aware why care about failures, let's take a look at some important techniques that could help prevent them in the first place. One of the crucial ones I would say is health check endpoints. Health check endpoints are API endpoints that return health status of a service as a response. Let's see how these could be useful. Implementing health check endpoints on your applications or services could help in detecting any possible failures due to other services or storage systems like databases or any third party application, for example, a service that sends SMSs to your customers. It would be better if you detect these failures sooner, which could in turn impact your system. And based on the response from a health check endpoint, you could take possible actions like having fallbacks or showing appropriate messages to your users, or take any other action that would help prevent further degradation of your service or application. Apart from validating response code, let's say a 200 OK, and the content itself, it could help in measuring response time of your application, like latencies. Or it could also help in checking SSL certificate expirations or validate correctness of DNS entries to ensure that your website or application is available frequ- at frequent intervals. Additionally, make sure that health check endpoints are secure to prevent any malicious attacks. Let's take a look at a sample health check endpoint. A typical health check endpoint could look like this. That could probably tell if the service is up by returning a 200 OK, like we discussed. Additionally, having more information related to memory, CPU usage, or DB connections, if necessary, could also help in early detection. A lot of these could also depend on the monitoring tool you're using, in the sense that if there is a third party application or service that you're using, and if it fails, your monitoring tool could detect that. So this is another way of having health check via the monitoring tool. Now that we've spoken about health check endpoint, there are several other techniques. Let's move on to the second one: throttling. Throttling is a way to channel resource consumption of your services by a single user or an entire service by throttling requests. This allows your system to keep functioning and ultimately helps in not breaching your SLA. Let's take a look at how or when to throttle. Throttle whenever there is an unanticipated burst of traffic from a single client or service. Well, there are techniques like auto scaling resources, which might help as well, but it could be slower at most times. A few ways of throttling could be rejecting requests from an individual user who has, let's say, already consumed the API n number of times, or degrade functionality for certain non essential or non critical services. Or you could also use load leveling techniques for smooth activity using a queue, let's say. This way, even though the processing is quite slow, it might not breach your SLA and your system is still functioning at some rate. So this is one another technique to mitigate failure. Let's move on to the next one: bulkhead. This approach is about separating elements of a service into different pools, so failure of one may not impact the others. Let's see what we mean by this. Each of your services may be handling a lot of customers or requests. An excess amount of load on the service might affect all the customers of the service, right? A large number of requests originating from one client could exhaust resources. So, how do we mitigate this? Partitioning service instances into different groups based on consumer load and availability requirements allows you to sustain service functionality for some consumers at least, even during a failure. So let's look at this diagram for connection pools that call different services. If service A fails, then only connection associated with that thread pool would fail and does not impact other services. All right. So this is one additional technique that you could keep in mind to mitigate failure. Moving on to circuit breakers. Circuit breaker pattern enables an application to check if a failure has been resolved and to retry only if it's fixed. Let's look at a very simple example. This is a very simple example, but yet gives you a clear idea about how circuit breaker possibly works. So let's say there is a cron tab or a program that periodically checks for availability of, let's say, a database. So on the left hand side diagram, if you see, we make a connection to MySQL server and we check if there is an error. If there is an error, this program stores the status of the database in a in-memory cache, let's say, and this cache is shared between this program that is running periodically and also the application. And if the database is down, then we store it as the status is down. Otherwise, we say the DB status is up and close the connection. Now let's look at the application side of it. If the storage status of the database is down, then we say the database server is currently not available and to try in a minute instead of retrying instantly. And if it's not down, then you let the control flow and then fetch the information you want from database. So this program is written in PHP, but I think it still gives a clear picture of how circuit breakers work in general. Of course, there are more complex tools to achieve the same. Let's say using Netflix's Historics for more complicated systems, or also there is a Go programming language equivalent like Historics Go or PyBreaker, I think, for Python. So you might want to check those out to understand more about how circuit breakers work depending on your use case. So let's look at another technique, capacity planning. Capacity planning is about estimation and predicting how much infrastructure resources would you need to support your customers. Let's take a look. Techniques like queuing theory help us come up with relatively accurate estimates to plan capacity. It not only helps in terms of provisioning the right amount of resources, but also aids in preventing any unnecessary spends. For starters, a few approaches described by Neil Gunther and Little's law could be of immense help. I'm not going to dive deep into each of these approaches as it's outside the scope of this presentation. However, those are very good starting grounds. Finally, let's learn a bit about types of testing that could be done to prep our applications for real world. Firstly, performance testing. Performance tests would help you evaluate your service's performance, especially in terms of responsiveness. How fast do your API return response so to provide a very seamless customer experience. Secondly, to load test. Load tests help you simulate the number of concurrent users you would have when you launch your application live and be prepared and ensure that your application is already battle tested before going live. And thirdly, chaos testing, or also known as chaos engineering, really helps. This is a technique to inject random failures to see how your entire system behaves and if it's able to recover and continue functioning without a single point of failure. These testing methods are quite vast, and there are different tools or frameworks available to set up and run these. But again, I'm not going to deep dive into each of these as part of this talk. However, I would recommend performance testing and load testing to be done for applications of any size to gauge robustness. Cool. So finally, the reason for talking about failures is because a well thought through system greatly elevates the likelihood of business success. As engineers, even though we might at times get ourselves excited with latest technologies and be focused on new frameworks, or nitty-gritties of getting things done. It's always important to keep business success with uptime in mind. With that said, I'd like to conclude my talk by adding links to some of the documents I referred to prep for this presentation. Do go ahead and read each of these links in depth to further understand the applicability of these techniques for your use cases. Thank you.